discuss about incident matrix and reduced incident matrix. Suppose this is a network. This network contain one node. This is one node. This is node number 2 and this is node number 3. So number of nodes of this network is 3. So number of nodes of this network is 3. Now to make incident matrix of this network, we have to convert it into its equivalent graph. So in earlier class I have already discussed how to create a graph. So this is node number 2, suppose this is node number 3 and this is node number 1. So this is a one branch, suppose branch A. This is a branch A. So from 2 to 1 there is a one branch. So this is a branch A. Suppose this is a branch B. So 2 to 3 there is another branch is B. And this is a branch C. So this branch is C. This is another branch C. And there is another branch. Suppose this branch is D. So this branch is D. Now how to create a graph from this network? We have done two things. Number one, passive network, passive circuit element. This is a passive circuit element, this is a passive circuit element, and voltage source must be short circuited. And number 2, current source must be open circuited. So using these two things, this portion will cancel out. So only this branch, this branch, this branch and this branch will stay here. This will remove because this is a current source. That's why it is open circuited. So number of branch of this network is 1, 2, 3, 4. So branch of this network is 4. Now we have to determine what will be the direction of current through this network. What will be the direction of the current through this network? This is a voltage source. So current will go in this way. This is a current source. So current must be go in this way. So current direction through this inductor will be along this direction and this current will be along this direction. So this is the direction of current. Now we have to put here. So this is branch B. So current direction of current is along this direction. This is current branch A. So direction of current is along this direction. This is branch C. So current direction is 3 to 1. So this is a direction. So this condition, this will be 3. So this is node 3. this is node 3, this is node 2, and this is node 1. So here I have shown the direction of current through this branch. Now we will develop incident matrix of this graph. So matrix means incident matrix of this graph or this network will be, suppose there must be a column and row. There must be a column and row of a matrix. So the branch of the graph will be the column of this matrix. So there is 4 branch. So this is A, this is B, this is C, this is D. So branch of the network or graph will be the columns of this matrix. Okay. Now this is nodes. So number of nodes will be the row of this matrix. So there are 3 nodes. So node number 1, node number 2, and node number 3. So this is the way to calculate the incident matrix of a graph. So the branch of this graph will be the column of this matrix, and the nodes of this graph will be the column of the row of this graph. So nodes represent row and branch represent column of this incident matrix. Now there are 3 things: number 1, +1, -1, and 0. So there are 2 things. If I take this branch, this current will incident. So this branch is incident on this node, and from this node is away from this branch. So if branch is incident on the node. So from this case, if the branch is incident on the node, then it will be -1. Now if branch is pointing away from node, then it will be +1, and 0 if the branch is not connected to the node, So 3 things will arise. One is, if the branch is incident on the node, then it will be -1. If branch is pointing away from this node, then it will be +1, and if the branch is not connected to the node, then it will be 0. So first, number 1, we will see the node number 1. This is node 1. 3 branch is connected to this node. So this is branch A. So from this node 1, this branch is pointing away from this node 1. So if it branch is pointing away from this node, then it will be plus 1. So in this case it will be plus 1. Okay. Number B. This B branch is not connected to this node 1. So this is 0. So this branch is not connected to this node number 1. That's why it is 0. Now C. See, this branch is pointing into this node 1. So in this case it will be minus 1, because incident on this node, this branch incident on this node, but this D branch is pointing away from this node 1. So it will be plus 1. Okay. Now number node 2. This is node 2. There are two branches connecting to this node number 2. So A is incident on this matrix node. So if a branch is incident on this node, then it will be minus 1. So in this case it will be minus 1. Now B is away from this node, so it will be plus 1. But C and D is not connected to this node, so that's why it is 0. Now node number 3. Node number 3, this A branch is not connected to this node 3, that's why it is 0. Now branch B. Branch B, this is a branch B and this is node 3. So this branch is pointing into this node. So then it is minus 1. So it is minus 1. Now C is pointing away from this node. So this is plus 1. And D is pointing into this node. So this is minus 1. So this is the incident matrix of this network. Now we will discuss what will be the properties of this incident matrix. The properties of incident matrix. Number 1, this is column, this is column, this is column, this is also a column. To this column, each column, this is plus 1, this is minus 1. The total is 0. Here is also plus 1, minus 1, total is 0. So here is minus 1, plus 1, total is 0. And also this plus 1, minus 1, total is 0. So we observe that the sum of the each column must be equals to 0. Through this column, if you add this, then it will be 0. Through this column, if you add, then it will be 0. Through this column, if you add, then it will be 0. So the properties of the incident matrix is sum of element of each column is 0. This is number 1. Number 2, this is node and this is branch. Okay, so this represent the number of nodes and this represent number of branch. So the order of this matrix, the order of this matrix will be n by b. So the order of this matrix will be n by b. Number 3 is, if you determine this matrix into a closed loop, then the determinant must be equals to 0. So if you determine this matrix into a closed loop, then the determinant value will be 0. So determinant of incident matrix into a closed loop of a closed loop will be 0 or is always 0. Okay, is always 0. So this is the 3 main properties of a incident matrix. Now if I notice this graph, then the number of trees, possible trees, will be n equals number of trees, tree will be n into n minus 2. So here is n is 3. So 3 to the power 3 minus 2 equals to 3. So if you calculate the number of tree using this formula, then it is not correct answer. Okay, so in this case you cannot apply this formula to calculate number of tree. So you have to know another process to calculate the number of tree of this type of graph or in this type of network. So to calculate the number of tree of this graph, we should know the reduced incident matrix. So what is the reduced incident matrix? The reduced incident matrix is, so reduce incident matrix will be this will be n minus 1. Branch will be same, but one row will be omitted. So what will be the reduced matrix? So reduced matrix is the incident matrix of a graph reducing one row of this incident matrix. Then it will be the reduced incident matrix. Suppose this a reduced incident matrix. Okay, now if I transport this matrix, so transpose of the reduced incident matrix will be A transpose will be this. So this is ABC. So this transpose will be look like this. So minus 1 plus 1 0 minus 1 plus 1, and this is minus 1 plus 1 0 0. This is the transpose of this reduced incident matrix. Okay, now if you multiply this by this, so So multiplication A and transport of A. So if I multiply this incident matrix with this transport of its incident matrix, so then it will be plus 1 0 minus 1 plus 1, this is minus 1 plus 1 0 0. So this is A and this is AT, that is transports of this reduced incident matrix. So it will be plus 1 0 minus 1 plus 1 minus 1 plus 1 0 0. The value will be, in this way you have to multiply. Okay, 1 1, so 1 0 0 0 minus 1 minus 1 plus 1 and minus 1 plus 1 plus 1 plus. So from this multiplication you can get 1, from this multiplication you can get 1, so total 2, and from this multiplication you can get another 1, so it will be 3. Now you have to multiply in this way. So this will be 1. No, from this condition, so this is 1, this is 2, so there will be 2. Okay, no, this will be here it is in this condition it will be 2. So along this way you can get 1 this, and along this way you can another this. First of all you have to complete this multiplication. Okay, from this multiplication you can get 3. From this multiplication if you multiply in this way, so this is minus 1, this is minus 1, this is 0, this is 0, so it will be minus, okay, this is, in this way you can calculate this. This is the 3 and this is the, if you multiply this row with this row it will be this. So minus 1 plus 1 and plus 1 plus 1 1, so total will be 2. Now if you multiply this with this, so what will happen? This is minus 1, this is 0, this is 0, this is 0, so this is another minus 1. So if you multiply this into this, so it will be, this is minus 1 0 0 0, there this will be another minus 1. So what will be the process for multiplication of this matrix? First you have to multiply in this way, you can get 3. Then you have to multiply in this way, then it will be minus 1. Okay, next you have to multiply in this way, then you will be get minus 1. Then this row and this column will be 2. So if you determinant this, so determinant of this portion, it will be, if I, so determinant of this portion, so determinant of A transport multiplication of A transports will be, this is 3 multiplied by 2 minus minus and plus, so this is 1, so this is 5. So the total number of trees will be, the total number of trees will be, so total number of tree will be determinant of multiplication of reduced matrix to its transport of reduced matrix. So in this case the tree is given by 5, but using this formula you have already reduced that the number of tree is 3, but this is actual answer is 5. This is not true. So in earlier class we have already said that we will discuss the limitation of this formula to calculate the tree. So if you want to calculate the number of tree from of this type of graph, you have to apply this formula. Okay, now we will discuss one problem using incident matrix. You have to calculate one incident matrix. Suppose this is a node number node 1, this is node 2, this is node 3, and this is node 4. So this is okay, and this. Okay, so here is direction of the, this is branch 1, this is branch 1, this is node, this is node, this is node, this is node, this is branch 1, this is branch 2, and this is branch 3, and this is branch 4, and this is branch 5. So from this graph you have to calculate incident matrix. Incidence matrix. So from this graph you have to calculate the incident matrix. So how to calculate incident matrix? So this is the rule. The branch will be along this direction. So column of this incident matrix will be branch. So branch is 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So total number of branch is 5. Now you have to write this node along this direction. Okay, number of node is this 1 node, this is 2 node, this is 3 node, this is 4 node. Now you have to think that minus 1 if branch is incident on node, and plus 1 if branch is pointing away from node. Okay, and 0 if branch is not connected. So this is the branch 1. So this is branch 1. So the branch 1 is incident into this node, so it will be minus 1. So this is minus 1. Now branch 2, this is branch is not connected to node 1, so it will 0. Branch 3, so 3 is pointing away from node, so it will be plus 1. 4, this is branch 4, so is away from this node, so it will be plus 1. 5 is not connected to node 1, that's why it is 0. So this is for node 1. Now node 2, this is node 2. So node 2, this branch 1 is not connected to node 2, so it is 0. 2, branch 2 is connected to node 2 but is away from this node, so it is plus 1. Okay. Now 3 is not connected to this node 2, so it is 0. 4 is connected to node 3, it is pointing into this node, so into this node this minus 1. And this is 5, so 5 is not connected to node 2, so it is 0. Now node 3, this is node 3, so branch 1 is connected from node 3, it is away from this node, so it is minus plus 1. Away from this node is plus 1. Now 2, branch 2 is pointing into the node 3, so it is minus 1. Now 3, branch 3 is not connected to the node 3, so it is 0. Now branch 4 is not connected to node 3, so it is 0. Now branch 5 is connected, incident on this node, so it is minus 1. Now node 4 is connected, branch 1 is not connected to this node 4, so it is 0. Now node 2, branch 2, this branch 2 is not connected to 4, so it is 0. Now node 3 is connected to node 4, is into this node, so it is minus 1. Now node 4, branch 4, the branch 4 is not connected to this node, so it is 0. Now node 5, branch 5 is away from this node, so it is plus 1. This is plus 1. So this is the incident matrix. You can check it. The sum of this column is 0. Sum of this column is also 0. Sum of the column is also 0. Sum of this column is also 0. Sum of this column is also 0. So incident matrix of this graph is given by this. Okay.